Hello everyone. Today we'll be covering question 5, part A2 of May-June 16, paper 42 of CIE A-level chemistry. The parts before this and the parts after this is completely unrelated to this question, and therefore we'll be treating this question independently. However, this data provided here will provide or prove to be very useful. The majority of the reason why candidates did not get this question right is because they didn't know what to do, not because they proceeded with wrong workings. They just didn't understand the question properly. So let's tackle this and see what's up. So it says first that cadmium ions are poisonous and need to be removed from water supplies. So that's our first important ion, so we write that down. And this is often done by adding a complexing agent. So the complexing agent will be mentioned later in the question. So in a sample of groundwater, the concentration of CD2 plus is 1 × 10 to the power minus 4 moles per dm cube. So that is our initial concentration. So we have to calculate the concentration of CH3NH2, or a primary amine, methylamine, needed to reduce the concentration of CD2 plus aqueous and dilute this by a factor of 1000. So what does this mean? So you have to reduce this to a factor of 1000. How is that done? That is done by 1 by 1000 times the initial concentration, which is 1 × 10 to the power minus 4. And that answer is 1 × 10 to the power minus 7 moles dm minus cube. And that is the second concentration, the final concentration. Now let's identify the other things that this equilibrium or this question includes. It includes this. And which of these equations contains the methylamine, and is this? So it's this equation basically, right? So this is CD2 plus and it produces this as a product. So whatever is being reduced from here is producing this, the other side of the equilibrium. And since it's in a 1-to-1 ratio, what you do is 1 × 10 to the power minus 4 minus 1 × 10 to the power minus 7. And that gives you 9.99 × 10 to the power minus 5. Right? Now this is the amount by which CD2 plus is being reduced. And what's being produced, or what's it being used for to produce this. So this is the concentration of this, all right? The product. This is the concentration of this product. So you write this equilibrium down again. So K stab is equal to CD CH3NH2 for 2 plus by concentration of CD2 plus and then concentration of CH3NH2 power 4. We have been given the value of this equilibrium and it is 3.6 × 10 to the power 6. So equals 3.6 × 10 to the power 6, right? So we know the concentration of this, which is 9.99 × 10 to the power minus 5. This whole thing is divided by was the concentration of CD2 plus, the final one, and that's 1 × 10 to the power minus 7 times concentration of something, this, times 4 is equal to 3.6 × 10 to the power 6. Okay? And so you bring this down. So x power 4 becomes 9.99 × 10 to the power minus 5 divided by 3.6 × 10 to the power 6 into 1 × 10 to the power minus 7. So that answer will be 2.775 into 10 to the power minus 4. And then you just root this to the power 4. 775 into 10 to the power minus 4. And your final answer of x is 0.129. and that is moles per dm cube. And that is the concentration of CH3NH2 or methylamine that's required to reduce this by a factor of 1000. I hope you understood. If you have any doubts, please leave them in the comment section below.